In this, we are going to learn what we call the first shifting property. Sometimes we also call FSP as the first shifting property. So the first shifting property is very useful when you also want to find the inverse Laplace transform. So this is the most common technique that we use for that. That we discuss in a different one and different video, and you can also find the link in the description how to find the inverse Laplace transforms. Okay, so what is the first shifting property? So if we have a piecewise continuous function which is of exponential order, we use these two conditions to make sure that the Laplace transform exists. So what is the result says that when you have this product, what product? E to a term, e to the minus at along with ft. So if you have this product and if you want to find the Laplace transform of that, so what happens? You find the Laplace transform of the original function, which is we normally call fs, and then shift s by a. So we just add an a to it. So remember, so when you have a negative a, we add a a. So there's a sign change. So there's a sign change. So that's something we need to remember. So there's a sign change. So we change the sign and add. That's how we remember. And also, if you want to remember the other way, you can also remember like that. So when you have e to the at, now we have a positive, and then it's going to be negative on the other side. So you can remember it either way. So it doesn't really matter. And also, like there's an easy way to remember the second one. We normally call this the eat function. And then what exactly happened is actually eat the part of the function. You can see you subtract a. So that's like another way to remember that. So when you have a eat and then you have the f function, you just subtract a, exactly the same amount a from that. So that's like another way. So it's like a eat function. So you can say eat function. That's like another way to remember this one. Okay, so let's try to look at a few examples now. So the question that we're trying to do is find the Laplace transform of the following functions. So let's look at the first one. So let's say we have e to the minus 2t times t. So here we can see that the function is ft, which is t. So since the function is t, and we know that from the table method that we discussed in the previous video, which is 1 over s squared. This is from the table, 1 over s squared. So what it says was the first shifting property says, so by the first shifting property, so what we can do, we first write the Laplace transform of the original function, so which is s squared, and then you're going to replace s by, so since we have a negative, you switch the sign, so that means you're going to replace by s plus 2, because switch the sign. So every s you replace by that, so that means you get 1 over, instead of s you write s plus 2, and then again square. So that's the answer. And then this one is valid when s is greater than negative 2. So we'll make sure this is positive. Okay, so that's the idea. So let's look at the next one. So let's say we have this one. So we have e to the 3t. So here you can actually use this one. There's a formula. So remember this formula. So we all know this eat formula. So it is e to the 80 is 1 over s minus 3. So if you know this formula, you can use it. But how to use the first shifting property for this one? So if you want to use the first shifting property, so what we can do, we have to figure out what is the ft function. So so you can guess that the ft function in this case is actually 1. That's why we don't write it. So that means, so it is ft, so which is equals to 1. That means the Laplace transform of that is from the table 1 over s. So we know that. So that means according to the argument, what we do, we write 1 over s and then replace s by, in this case, you can see a is 3. So that means it is going to be s minus 3 with opposite sign, s minus 3. So that means the answer is 1 over s minus 3 as expected. So that's the answer you should get, and you get that same answer here. And again, this one is valid for is bigger than 3. So that's the condition for that. And that's how we do it. So let's do a couple more examples. So let's look at the next one. So we have e to the minus 2t sine 3t. So that means our function is sine now. So sine from the table we know that it is squared plus a in this case is we have omega, actually omega is 3, so that means 3 squared means 9, and omega goes to top also is 3. Now what we do, we're going to replace s by, we can see it's a minus, so it's a plus, so it's become minus, so that means it's going to be plus, so it's plus 2, so that means the answer is 3 over s plus 2 whole thing squared plus 9. If you want, you can also distribute this one and write it like this. So you can see if you distribute, you get 3 and you get s squared plus 4s, and then you also get 4 plus 9, so you get 13. So either way is okay. So you can write one of the versions, so it doesn't really matter. So let's look at the next one. So let's say we have this. So we have e to the 3t cosh 4t. The cosh is a hyperbolic function. So hyperbolic function. Remember, like when you hyperbolic function, only thing what happen is the denominator switch the sign, plus become minus, and that's the only difference. So that means, so you're gonna get it is in this case omega is 4, so it is s squared minus 4 squared, so which is 16, and there's a cosh, that means s gonna go to the top, and then what you will replace s by. So what happened here? So we have a 3 which is positive, so that means going to be s minus 3. So so that means it is each s you replace by minus is s minus 3, and then in the bottom s minus 3 squared minus 16. So that's the answer. Also, once you get familiar, you can actually directly write this answer. You don't want to write this extra step, the intermediate steps. So you can directly write. So, but you have to think about. Okay, so what do you do here? And then you know that. So just think about these steps. You don't want to write it. Just think about the cosh going to go s over s squared minus 16. So we know that. So just thinking, and what you can do is you just ignore this step and you directly write the answer. So directly write the answer. That means each s going to be s minus 3 squared minus 16 over s minus 3. So you can also directly write that answer without going through the intermediate step. So that's the intermediate step. You can actually ignore this one. Okay, so let's look at the next one. So we have e to the minus 3t and then ut minus 1. So what is ut minus 1? Which is the unit function. So unit function, that means it is 1 after 1. There's a 1 here. So that means after 1 it is 1. That's the unit function. And then from the table, you know that the Laplace transform of the unit function is e to the minus as over s. So because of that, and then we can, so in this case a is 1, so so we can write it using the property. So it is e to the minus s over s. That's the Laplace transform of the unit function, and then you replace each s by, and then you can see here a is negative 3, so that means you replace s by s plus 3. So the answer is e to the minus s plus 3, you need a parenthesis there, over s plus 3. So that's the answer you get. Actually, I'm going to do this problem using another technique. You can also use the second shifting property. So what is the second shifting property says? Which says that the Laplace transform ft minus a ut minus a. See the format. They have the exact same format. And then the same minus a goes here. So e to the minus a is fs. So here this is just fs. That's the original Laplace transform of the original function. So let's see how we can use this idea just to know the trick. So what we do, we can start with the problem, and you will see that we do not have the form that we need. It has to be t minus 1 format. So there's no t minus 1 format. So what we do, we can actually recreate that. So how to recreate that? So so what we can do is, so this is the idea. So we can leave like some space in front, And then let's try to rewrite e to the minus 3 and what we want. So what we want is t minus 1. That's what we want. And then u t minus 1. But when you do that, there's a problem. So you can see you multiply these two numbers, that means you're going to create a 3. 3 means e to the 3. So just to cancel that, what we're going to do, we're going to write e to the negative 3 in front, which is just a number. So that's the idea. So you're going to manipulate it. And then you can actually pull that number out of the transform. So it's e to the minus 3 comes out. And then you can rewrite this one as e to the minus 3 t minus 1 ut minus 1. Now what we can do is we can use the second shifting property here. So let's use the second shifting property, SSP. So what happened, e to the negative 3 we leave, and then second shifting property says you just need to figure out what is the a. In this case is negative 3, so that means it is going to be s negative, so we have e, not s, so we have e, so we have e to the negative 3s that we have, and then multiply by the original Laplace transform. So which is, you can see original function, this is the original function, which is u to the t. So that means it is going to be e to the, so you can see that, yeah, here actually the original function is this one, because that's the original function, not the u one. So that means it's a e, that means it is, so what we do, we're going to find the Laplace from the original one. Original one in this case e to the negative 3t. So that means it is going to be 1 over s plus 3. So that's what you get for the bottom. Now what we do, just do the algebra, and then you can see when you simplify the top, you can write it like this. So you can write this one as e to the negative, if you pull the s minus 3 term out, you can write it like that, and actually it's going to be plus now because the negative sign, plus, and then over s plus 3, and you can see this now answer match with the previous one. So this is how we use the second shifting property. So let's try to do two more problems also, just to know like other terms. So how about this one? So let's say we have 1 plus et plus e to the 2t plus e to the 3t. So in each one, if you use the first shifting property, the function is ft equal 1. All of them ft equal 1. That means if s equal 1 over s. So that means what you just need to do is just add the opposite sign of this one for each term. So the first one, actually you can see this is like e to the 0. You can look at this as e to the 0, the first one, just to know the technique. So that means I'm just gonna do it directly now. So what you do, so it's a 1 over s, just add the opposite sign. So it's a 1 over, in the first one actually s minus 0, so which is s. So the second one going to be 1 over, this is here you can see there's a 1 in front, so that means s minus 1, and the second one 1 over s minus 2, the last one 1 over s minus 3. So that's the answer. So you can directly write it like that. So just do the mental calculation, and then let's do the last one. So this one, so let's say we have, so this is also very similar to the previous one. Only thing that you need to do is we have 3 terms, and then every time you have different functions. So do like a mental calculation, and then first one you can write as, you can say 2 times, because there's a 2 in front, t squared. T squared means t squared. So that means the transform is, what's the transform of t squared? Is a polynomial. So it is factorial 2 divided by s to the 2 plus 1. So that means because of that, so it's going to be, so it's a 2 over s to the 3. It's not s now, it is s plus 4 to the 3 because of the e term. And then minus the next one, this t, that means 1 over s squared. So that means it is 1 over s plus 4 squared. And the last one, you can see phi is a constant. So the function is 1 in this case. That means 1 over s. So it's 1 over s plus 4. And then you can also simplify this a little bit and write it like this. So this is how we use the first shifting property to get the answers. So you can try these problems as practice problems now. You can try these problems as practice problems, and then you can, if you know the answer, you can put in the comment section. So thank you so much for watching.